Okay, the purpose of this video is I'm sure a lot of you guys that have hit and miss engines, throttle governed engines, etc., are curious or are just starting to understand the ignition systems that are used on these engines. This that I have here is an ignition coil assembly called a buzz box that comes out of a Model T engine, car, what have you. But these are pretty popular with hit and miss engines and throttle governed engines for producing a spark for the engine. You'll see these at flea markets. Sometimes you'll see them at the swap meets, engine shows, stuff like that. But today what I want to do is explain to you the internals of this, how it actually operates, what makes it operate, and how you can fix them pretty easily. When you get one of these, there are two small nails on a cover. If you look around here, let's see, is it on that one or this one? No, it has to be on this side. You notice how this cover looks like it comes off, and this side it doesn't, because it has that piece of wood that goes along the bottom. Look for that side where you can slide that piece of wood off. There should be two small nails located here, and then this piece of wood will slide off. You know, you might have to pry it. It's been there well over 100 years, so you might have to pry it off. If you buy one that's already working, I wouldn't tamper with it. If it's working, that's all that matters. But I found 4 of these at the last show that I went to at $5 each. They just didn't work, or nobody wanted to take the time to try to get them to work. But when I go through the procedure here of what it takes to get one of these working, if you find a cheap one, go ahead and buy it, because 9 times out of 10 you'll probably be able to fix it yourself. So the first thing I want to talk about is how it is internally wired, so you have an understanding of how it works. I have a diagram here. If you'll notice here, and also here, you have these 3 terminals. The one on the bottom would be coming from the battery negative post. This one at the top would be coming from the battery positive post, and this is your spark output. So let's start there. So like I said, you have your negative post on the bottom, you have your top post at the top, which is positive, then you have your spark post. Internally, you have a set of coils and a primary coil. This primary coil has an iron core that comes up through the top of the box. Give you an idea, here's the coil, here's the other coil, and then if you look really close, see if I can flip it up here, or I'll even take it out. You'll see that here is that iron core I was talking about. It goes up through the top, and you can see it right under here. Okay, so we have the 2 coils, and then also the primary coil, which is part of that iron core. And that actually comes out of the center of these 2 coils. When you first open up one of these boxes by pulling the door off, you're going to find a lot of black tar looking stuff, and you're not going to see nothing but that black tar. I actually took all that black tar out of this one here so I could demonstrate to you what the internals look like on these buzz boxes. So it's all out. I took it all out. You have to scrape it all out of there. You have to really be careful about not yanking on wires and stuff, but that's what's internal to them. But a lot of times you don't have to take all that stuff out of there to be able to repair them, because this one that I found at swap meet only actually needed the condenser. And I'm going to explain how this is connected to get this to work. It's the condenser, which is here. That's the condenser. There's a piece of glass in there which separates the condenser from the coils. The only thing that I could think of, maybe somebody else would know, but the glass actually separates these coils from the condenser, either just through vibration moving around, or it might have an electrical principle for being in there. I'm not really sure. It doesn't really matter because it just separates the condenser from the coils. Okay, so back to the diagram. We have our two coils, you saw those. We have the primary coil, which is internal, which has the iron core. And then you have your condenser and that piece of glass. The way it is wired is you have your negative terminal down here coming from your battery. It goes through this primary coil, goes to this side of the condenser. From the condenser, it goes back up to this terminal here. That would be all the negative side. So it goes up through the coil, back through to this side of the condenser, from the condenser, or capacitor, whichever one you want to call it, and goes up to this terminal here. The positive side goes to one of the secondary coils, and then from there it also comes up and goes over to this terminal at top, which I'm going to show you right now, which is the first one, the one that came from the capacitor is here, and the other one that I was talking about, the positive one, comes here. Let's go back to the diagram. So the other side of the condenser capacitor, there are two terminals on the capacitor. So one would go to the negative side, which this is all really negative, and then one would go to the positive side. And the reason for the condenser capacitor is to eliminate the amount of sparking that is done here at these points. And I'm going to show you here in a minute just how much arcing there is, but it actually makes the longevity of these points last longer. I do believe that was the reason for the purpose of it. Okay, so we have our positive coming up to this terminal. We also have our negative coming up to this other terminal. And like I said, on this unit, like I said, you have the negative and you have the positive. Now, if you look in here, if I can get it to where if you look in there real close, you'll see those two sets of points that are up in here. You'll also see that iron core that's sticking up there. Okay, the principle of operation is when you hook up the 12 volts to here and the negative to here, and if these points are closed, you're actually creating a complete circuit. So the complete circuit would go from negative through the primary coil, across the capacitor, up to one set of points. That would be the negative side. Then the positive side would come up to here and connect to the other set of points. Now, with them being in the position that they're at, they're closed. So you have a completed circuit, negative to positive, through the primary coil. Now, whenever you send voltage through a coil of wire, you actually create a magnetic field. That's the reason for the iron core. So once when you connect your positive and your negative to your battery, you actually created an electromagnet. This electromagnet is going to pull these points apart, breaking the circuit. And it's going to happen so rapidly, opening and closing, because when the points are open, the field collapses that was created here. It's going to collapse. It's going to induce that field into these secondary windings, which produces a greater voltage to produce the spark. So two things are happening here. One, it's becoming an electromagnet, and two, it induces a voltage when it collapses into the secondary coils. When the secondary coils get that induced voltage, it actually increases the voltage amount, and maybe some amperage also, but it actually creates a spark as long as this connection goes through the spark plug back to ground or to this side. It completes the circuit. So on these two terminals, as I explained, you have one that is positive and one that is negative. The two terminals that are in here are connected to those two set of points that I pointed out. So there's the connection. So when that connection is made here, when that connection is made, then the coil, the primary coil, is energized, and it actually makes a magnetic field pulling these 2 points apart. When that connection here is broken, then the field collapses, inducing a voltage here, and also releasing the points to where they come back together again. So it's just a constant thing, and I'm going to show you on one over here that I got connected, just how fast that operation is. But 9 times out of 10, when you buy or purchase a coil that is not working or a buzz box not working, generally these coils, very seldom, on the amount that I have worked on, very seldom are they broken, damaged, or the windings are still good, usually on the primary and the secondary. The glass, it's never broken. The capacitor is usually the main problem with these buzz boxes. So what I've taken is I've purchased, this one is a, let's see if I can get it to focus here, 2.2 microfarad, 2.2K microfarad capacitor that I have actually connected from the positive to the negative, just like it is in here. See, it goes from, the capacitor goes up to here to this point. Also the positive goes up to here, which is connected to this one. And then the negative side of the capacitor goes up to the tall terminal. So like I said, you got the negative on the tall terminal, then you got the positive on the lower terminal. These two connections, this one here, let's see if I can get a good video here. This one here and this one here are both connected to one another. It makes a connection all the way across. So it doesn't matter which one you connect one side of the capacitor on. It doesn't matter. It could be this side or this side. The other side of the capacitor has to go to this upper piece here that you see, which goes here. So you're just taking the place. You're using this capacitor in place of the one that's internal. And you don't have to disconnect it or anything. You can just stay right there. It won't affect the operation whatsoever. So like I said, once when the battery is connected, then the operation starts. So this turns into a magnetic field. It induces a voltage in both your secondaries. It also creates a magnet here to pull these contacts apart. Once when the contacts are taken apart, that's when that magnetic field is induced in here. And also, it drops the circuit off because these points are now open. So the magnetic field is gone, the magnet is gone, so these 2 points come back together again. And then the procedure starts all over again. So it's a rapid succession. These points go back and forth. I don't know what the rate is, but they go back and forth pretty fast to create a contact and then create a non-contact. It's like a switch going on and off hundreds of times, maybe even in thousands. It happens pretty rapidly. I'm going to show you here in a minute. So that's the internals of this. So there are ohms. You can take an ohm meter and ohm these coils out. I think it's like 3,000 ohms on your secondaries, which you could check from this point to this point, but I'm not going to go into the detail of the specifics of that, because if you can get a capacitor like the one I have here, if you can get a capacitor like this and go across these 2 points, like I said, and it work, then I wouldn't worry about the coils. If the coils are bad, you're gonna have to go through the trouble of pulling all that stuff out of there, and it's just a lot more work and time to be able to do all that. It took me a while just to get these exposed, but like I said, 9 times out of 10, you're gonna find all it has is a bad capacitor. Another thing you might want to do is take these connections off. There's one at the top and then there's one at the bottom, and clean these contacts up real good. I took a wire brush to these and cleaned them up real good to where it makes a better connection. But you want the coil contacts to touch like this one is. You'll see the 2 contacts there. They're both touching. I can open and close them with my finger. I don't know if you can see that. But you want them to touch, and you want the clearance. I think it's maybe 32 thousandths between the magnetic core, which is that round thing that you see in the center, and the points themselves. A clearance about 32 thousandths, give or take. It's adjustable here. You can adjust that by pulling this plate down closer to the points. You just want to make sure that this upper plate is touching the lower plate at the points. Make the connection, because the coil, once it becomes energized, it's going to pull that plate down to itself, that lower plate, and it'll make and break the circuit. So clean up all your contacts, put a capacitor on it like I showed, from here to over here, and you'll take the place of the old capacitor that's sitting here. This one here. You'll take the place of that. You don't have to worry about taking all that stuff out of there if you can put a capacitor across those 2 points and be able to get it to work. Now, I got one set up over here. What I'm going to be doing is I'm going to take the negative terminal of my battery and I'm going to hold it on here. I'm going to take the positive terminal of my battery, I'm going to hold it here. I'm going to try to hold the camera to where you can see the action that's going to be happening with the points that are going to be open and closing here, like my finger's doing now. That coil is going to become a magnet. It's going to pull this plate down. It's going to break the circuit. And then when the circuit is broken, then everything returns to its normal state, which comes back together and touches the upper plate. So it's making and breaking, just like flipping a switch, off and on, off and off, off and on. This is where the spark is going to come from. You have to have, just like if the spark plug was inserted into the engine, screwed into the head, or the side of the cylinder, depends on the engine, it's going to be grounded here on this side. So that's why I have the ground electrode. It's going to be connected to the negative side here. So you're going to see some sparks coming to the spark plug, and also you're going to see some sparks at the points. So let me see if I can get my camera set up where you can see what's going on here. Sorry about the crazy camera work. I'm doing this out in my garage and I'm not a professional. Okay, so like I said, I'm going to take the positive or the negative on the bottom, which I'm holding right now. I'm on the positive. I'm going to make sure that my spark plug is pretty close. Then I'm going to take the negative side and I'm going to touch on the other side of the buzz box. Then you're going to actually see the sparks. You'll have to look up at the, see if I can get them close enough here where it'll actually work. The sparks that are at the points. You can also see the spark that is going to the plug. Closer so you can actually see the points. They're going to be sparking. There. Now on the installation of this, you can solder some wires to these points, to the negative, to the spark, and to here. Like I said, this is the positive. This will go to your battery, so you can solder a piece of wire from here going to your battery, positive side. Then over here, the negative side, you can solder a piece of wire and put it on your negative side. The thing is, you have to come up with a switch that is going to either make and break the negative side or the positive side. Most people use the negative side. Now that's where the timing comes in. You have to have a switch on your engine to where it makes contact with the negative side when it reaches that point of either top dead center or so many degrees before top dead center when the spark is required for the engine. So a timing event needs to be made on the negative terminal to where you are making contact to that negative terminal through a switch or whatever you're using for the timing event to allow voltage to this negative terminal. So it's actually, you'll have to look that up to figure out how guys are doing timing switches, either off the cam or there's different ways that people are doing it. But you'll have to look that up to, they call it a timing switch, to where you're making contact with the negative terminal of the battery and here, the negative terminal here, when the engine is required to have that spark. That's part of the timing sequence, but that's something else I might make a video on later on to give you an idea. But I just wanted to talk about the operation and principle of the buzz box, so you have an idea of what to look for. So if you see these at the flea markets and stuff, go ahead and buy them. You know, they're fairly cheap, and put the capacitor across there, like I said, and clean up your contacts. You got to make sure you have good contacts and a good capacitor for these to work. And 9 times out of 10, they will work. You don't have to actually go into them, because going into them is really a mess because of all the black tar stuff. So I'm going to stay on this diagram if you want to pause it and take a look at how it's wired there. You can actually see the wiring in there, how it goes from the negative to the primary to one side of the capacitor, goes back up to one side of the terminals, which I've showed you over here, which would be this one. And then the positive side goes from here. It also goes to the secondary coil, and then up to this other contact to the other side of the capacitor. So I'll leave that right there for a minute, and then you can pause on it, and maybe you'll get a better idea of its operation. If anybody has any questions, comments, criticism, whatever, throw it in the comments down below. I'm going to try to make another video on how to set up your timing switch for your hit-miss engines, throttle governed engines, the ones that use spark plugs and not an igniter type ignition. There are usually 2 types. you have an igniter type ignition or a spark plug ignition. This buzz box uses a spark plug ignition. So again, this is the Model T buzz coil, the condenser or capacitor, glass, and your two coils, secondaries, and your primary. And that's how they're all wired in. And I just showed you the operation of the buzz box here. So it gives you an understanding of how those points open and close, making and breaking the circuit within the box. So that's pretty much it. If you get any comments, questions, just put them down below, and I'll see if I can answer each and every one of them. These are pretty simple. There's not really that complicated. Main thing is to get your contacts clean, clean them up really good, and try a capacitor from the tall terminal to the short terminal. And like I said, these two short ones are connected together, and these two top ones are connected together. So it doesn't really matter which side you go on, it's still across the plate between the two and makes and breaks the circuit. If you look really close, you can see there's what looks like another contact behind the two contacts you see there. That's just the rivet that actually holds the piece together. So like I said, it's adjustable, so get it to where these two contacts are touching each other, and if you have a good circuit all the way through the box, then this iron core will turn into a magnet and pull that set of points down and then open and close like I showed in the demonstration over here. So I hope this helps some of you guys out there who want to use these for spark on your hit and miss engines. I like using the old Model T buzz coils because that's what some of them would have used back in the day on their hit and miss or throttle governed engines. So there you go. Like I said, you got any questions, leave the comments down below and I'll answer all of them I can. I appreciate you watching this video, and this is Warren from Stationary Engines Worldwide. You can find me on Facebook, on Instagram, and right here on YouTube. Again, that's Stationary Engines Worldwide. I appreciate you watching. Have a good day.